Hello, I'm Sean Wu. Today we will show you a demo of using CAT scan to pinpoint the precise locations of sound sources in 3D space. CAT stands for Computer Aided Tomography. Here, CAT scan refers to displaying a series of 2D sound pressure maps separated by a very small distance in 3D space. CAT scan is accomplished by using the Helmholtz Equation Least Squares method to visualize the sound pressure distribution on a 2D plane in 3D space. The hardware needed for performing CAT scan is the sound viewer system. To demonstrate the functionality of CAT scan, we utilize two small earphones. Tests are conducted inside a non-ideal and crowded office with unknown acoustic room constants. The first example involves one earphone emitting heavy rain pouring signals which are downloaded from the internet. The frequencies of these broadband sounds range from 20 to 8,000 Hz. Note the changes of sound pressure maps on the left side as the depth changes on the lower right corner. As scanning approaches the source, the focus of sound pressure map becomes sharper and sharper. Eventually, as scanning moves away from the source, the sound pressure map becomes out of focus. At 0.327 meter with respect to the center of the microphone array, the focus becomes the sharpest, which corresponds to the exact location of the earphone. In the second example, two side-by-side earphones with a separation distance of 4 cm without depth offset are used to produce broadband signals, heavy rain pouring, and white noise, both of which are downloaded from the internet. The measured SPL values are 30 to 55 dB and the frequencies are 20 to 8,000 Hz. Once again, as scanning approaches these sources, the focus of the sound pressure map becomes very sharp. In this case, two earphones are identified simultaneously when scanning at 0.4522 meter with respect to the center of the microphone array. In the third example, two side-by-side earphones with a separation distance of 1 cm without depth offset are used to produce the same broadband sounds as before. The measured sound pressure level are 30 to 55 dB and the frequencies are 20 to 8,000 Hz. Results show that at 0.465 meter, these two earphones are identified precisely. In the last example, two earphones with a separation distance of 1 cm and a depth offset of approximately 1.5 cm are utilized to produce heavy rain pouring and white noise signals. The measured sound pressure levels are 30 to 55 dB and the frequencies are 20 to 8,000 Hz. In this case, the first earphone is identified as 0.3551 meter and the second earphone is at 0.3692 meter with an offset distance of 1.41 centimeter, which is very close to the estimated 1.5 centimeter. In conclusion, sound viewer can be used to locate a plurality of sound sources in a non-ideal 3D space over the entire frequency and dynamic ranges at a very high spatial resolution through CAT scan. This case study shows that by using CAT scan, we can achieve a spatial resolution of 1 centimeter separation without depth offset or 1 centimeter separation and a 1.41 centimeter depth offset in the entire frequency range of 20 to 8,000 Hz. CAT scan is simple to understand, easy to run, and its results are self-evident. Thank you very much for your attention. For more information, please contact me at seanwu@signal-wise.com.